and relook at the, remember when we drew out our first triangle and we drew out here this ordered pair? This ordered pair here was some x and some y value. When it flipped into the next quadrant, what changed? It was negative x and positive y. When it flipped down into the next one, what did it do? Good. When it flipped down here, it was negative x and negative y. So they're still saving all the same characteristics. And then lastly, when we flipped it into the fourth quadrant, we flipped it over to the first quadrant and we had positive x and negative y. Now, that's how all of this stuff works out. What's nice when you get into this unit circle mumbo jumbo, it's nothing more than your x's and your y's. It's your ordered pairs. It's your cosine and your sine. Remember, cosine is x over r. Sine is y over r. Tangent is y over x. All you need to be able to do is to generate your ordered pairs for 3 angles. Every one of the angles that we work on in this class is going to be working with some reference angle of a trig function that works. It's going to be a special, 30, 60, 90, or excuse me, 30, 60, or 45. We will work with the quadrantals still, but those are very simple to work with. Now, as we go through this again, we're looking at 30 degrees, 45 degrees, 60, and 90. What were those in terms of radians? The easiest one to start with is 90. What was 90 in radians? Half pi, good. So this was pi over 2. That meant 45 was at pi over 4. And what was 60 in terms of radians, remember? Remember, multiplied by pi divided by 180? Pi over 3. And this one was pi over 6. Those were your radians and your degrees. After that, when you look back to your table, when we're going with our ordered pairs for this, we built it off of the right triangles. For example, if I'm looking at my ordered pairs, remember it goes x, y, it goes cosine, sine. What was the cosine of 30 degrees? Well, you did this yesterday. Cosine of 30 degrees was root 3 over 2. The sine of 30 degrees, opposite over hypotenuse, 1/2. That's where this stuff comes from. It's coming right out of the 30, 60, 90, 45, 45, 90. These values are just going to mirror each other with different signs, SIGN, positives and negatives throughout the 4 quadrants. I'm going to go to the 60 degree. I'm going to move up to the 60. If I'm at 60 degrees and I want to find the x-coordinate, which means I'm looking for the cosine, cosine of 60 was adjacent over hypotenuse, 1/2.
So then do the x and y just switch for 60 and 30?
Yep. Because don't they just switch positions in what you're looking across from you? Look at what's opposite now. Now your sine is root 3 over 2. And then when you're at 45 degrees, isn't your opposite and your adjacent, aren't they the same thing? That's why your cosine and your sine at 45 are the same value. Since your opposite is 1, your adjacent is 1, that means, well, your sine would be 1 over root 2. Your cosine would be 1 over root 2. When we rationalize that, we write it as?
Root 2 over 2.
Yep. Those 3 angles get you everywhere in the circle. All it is figuring out what the reference angle is in relation to it, and then changing the positive or negative if you have to. Okay. Quick review. I know this came up earlier today. People tended to forget what quadrants things were positive. What's positive and negative in the first quadrant? Both positive. Good. In quadrant 2, what's what? Negative and positive. Now, that means in terms of trigonometry, what's positive, what's negative?
Negative cosine, negative.
Negative cosine, positive sine. Everybody okay with that? Okay. Third quadrant.
Negative, negative.
They're both negative. Good. And now in the fourth quadrant,
Positive, cosine, negative.
positive and negative. Remember, these are your x's and your y's. Now, I've only discussed by looking at that, these are just sine is positive, cosine is positive, cosine is negative, sine is positive, cosine, negative, sine, negative, cosine, positive, sine, negative. What about tangents? When I'm talking about tangents, what am I doing to solve for tangent?
Diagram.
Their tangent is only positive in the first quadrant, because in all the other quadrants there's a negative.
How do you find tangent again? What is the value of tangent? Think about it in terms of x, y's, and r's.
Cosine over.
It's y over x. So if it's y over x, that means it's positive divided by positive, therefore tangent is?
And
So
the
it's-
bottom line.
Tangent's positive. Here I have a y over x, which means tangent is? Negative divided by negative is? Positive. So tangent is positive in Q1 and Q3. Then lastly, tangents can be negative again in the fourth quadrant because you have a positive and a negative value. What about the inverses? Do the inverses keep the same signs, positives and negatives, the SIGN, as their big brothers, shall we say? Yeah. So cosecant, if cosecant is positive, that means sine had to have been. So where is cosecant positive? Yeah, 1 and 2. Remember, your inverse trig functions match the regular parent trig functions whenever you're dealing with their positive or negative values. They're going to be identical. The thing that's going to happen is, if I wanted to say find the cosecant of 30 degrees, if I want to find the cosecant of 30 degrees, I'm going to find the sine of 30 and then do what to it? Flip it. So what's the sine of 30? 1/2. So what's the cosecant of 30? 2. All right. So let's look at some examples, because now we are not using calculators anymore. You're going to be doing all this stuff by hand. Finding reference angles and building off of your unit circle. Again, all you have to understand what to do is work with these 3 angles. The quadrantals are a piece of cake. The quadrantals are going to be the easiest stuff to work with. Let me show you an example. I want to look at the cosine of negative 4 pi over 3. And how I'm going to do that without anything else is to first draw the angle. Draw the angle and find the reference angle. It's negative 4 pi over 3, which means I have to go the other direction. 3 goes into 4 how many times? How much is left over? 1/3. So it's going to be 1 1/3 pi is our rotation. So here's 1 1/3. What's the reference angle to get me back down to the x-axis? I don't know what the 60 is.
1 pi over 3.
Thank you. So my reference angle is pi over 3. I know, I saw that. It was pretty good. So my reference angle is going to be at pi over 3. So what I'm going to do here is I'm going to look at my ordered pairs for pi over 3 in the first quadrant. If I'm dealing with cosine, is that the x or the y value? It's the x value. So the cosine of pi over 3 is the x value. So pi over 3, like you said prior to rolling your eyes, is 60 degrees. Cosine, if you look at your right triangle, if you don't remember off the table here, 1/2. So that means the cosine is 1/2 in the first quadrant. When I come to the second quadrant, what happens to cosine?
Negative.
Your answer is -1/2. Again,
That's the
your,
answer?
it's your answer. Cosine of -4π/3 is 1/2.
Wait, we're
Negative
not
1/2.
looking for, oh, we're looking.
Oh,
Yep.
so we're just trying to calculate
Yep.
that by
Everything
using the
is
graph.
everything is built off of the first quadrant, but your SIGN, the positive and negative signs, switch depending upon the quadrant that you're in. The whole idea here is to find that reference angle. That reference angle will be in the first quadrant for now. We'll eventually get to doing like a pi/12, but that's not for a while. Okay, you're gonna be fine. It's a formula. It's like finding the area. Okay, not so scary.
Tie.
All right, sine of 7π/4. I'm gonna keep this with us. Sine 7π/4. Again, 4 goes into 7 how many times?
2 times. Or 1 time.
1 time. And how many are left over?
Minus 4.
3. So we rotate around. There's 1 3/4. What is the reference angle? Pi/4. Very good. So my reference angle is pi/4. I'm in the 4th quadrant, and I'm working with sine. In the 4th quadrant, sine is negative. So go to your reference angle for pi/4. Remember, pi/4 is the 45, 45, 90. If you have a pi/4 and a 45 angle, what does it sound like they have in common? 4. And what do you know about the sine or the cosine of a 45? It's the same thing. Root 2/2. So here it's going to be root 2/2 for the sine value, which means in the 4th quadrant it is,
Negative.
your answer is negative root 2/2 for the sine of 7π/4. We're building reference angles off of the first quadrant to allow us to do all of these by hand. Okay?
You always do the quadrant in the first one.
Yeah. The first quadrant stuff, you don't have to write out that first quadrant. You don't need to. If you understand how to draw your right triangle, if you can just draw up the right triangle and just do your sine cosine value, know that 60 is pi/3 or 30 is pi/6. If you understand the quick radian calculation, you're going to be just fine. There's multiple ways to set these things up.
So you don't even have to do the first quadrant part there.
What do you
Since
mean?
since it lands in the 4th quadrant, you don't even have to, like, you're just showing us the first quadrant.
Yeah, because the reference angle of pi/4 in the 4th quadrant is the same angle in pi/4 in the 1st quadrant, except the sine of sine is different. And we all know how to place ordered pairs on a grid if they're positives and negatives. The only thing that's different is saying it's at -3 and 2. It's a cosine and a sine value as opposed to a numerical plot. All right, let's do tangent of 5π/6. Oops, wrong button. I can't believe I forgot to do that for so long. It's so much easier. Tangent of 5π/6. We haven't done a tangent yet, so this might take a second. Find your reference. Is 5π/6 greater than 1 pi? It's less than 1 pi, you guys agree? It's more than halfway though? So what quadrant is that? Second quadrant? How much pi is left?
1/6.
Good. Does everybody agree that your reference angle is pi/6? Takes me pi over 6 to get down to that, which means in my first quadrant, pi over 6. In the first quadrant, pi over 6 has the ordered pair of root 3 over 2 and 1/2. Now, when I'm dealing in the second quadrant, one of those values is going to become negative. Which one? Yeah.
Oh, what I was gonna ask, how'd you get the ordered pair of the over 6?
I just rewrote it. The 30-degree angle, remember the sine, or excuse me, the cosine of a 30 is root 3 over 2.
So we're only gonna get like good numbers like that, like pi over 6, so we know that it's that.
Yes,
Okay.
yeah. Well, eventually, you're going to get something like pi over 12, but that'll probably be at the end of chapter 14.
Okay.
We're not going to do that quite yet. That's going to take a while to get to that. Everything you get right now has to work off of 30, 45, or a 60.
Okay.
Nothing. If it doesn't, then you might have done something wrong,
Okay.
or you have a calculator in your hand. Okay. So over here, that means this ordered pair is going to be a negative root 3 over 2 and a 1/2. Now, when I'm working with tangent is y over x. Do you agree? So that means I can write this as 1/2 divided by root 3 over 2. Do you agree with that? When you're dividing by fractions, what are you doing? Yeah. What does that become then? There's your answer. Now, it's in second quadrant though.
So it's negative.
Negative root 3 over 3. Yes.
And you just look at the table?
Yes.
Can't you just do,
Yes.
no, this is, I don't know, since they're the same denominator, can't you just do,
What's that?
since they're the same denominator, can't you just do the numerator?
There's another little shortcut that happens here, guys. These things are all built off of 30, 60, 90, 45, 45, 90. If you are looking at a 30-degree angle and you have that triangle right in front of you, isn't tangent opposite over adjacent 1 over root 3? Root 3 over 3? Do I need to go through the whole rigmarole of typing all this out?
I
No.
looked at my chart.
Yeah. Well, you're not going to have that in front of you at all times.
But if I burn it in my mind, it will.
If you burn it in your mind, it'll be there, yes.
Or if you get tattooed on your arm.
If you tattoo it on your arm, yes. I will make you wear sleeves.
Right
All right. Again, when you're working with tangents, if you're working with tangents or cotangents, it's very simple just to kind of remember what the right triangle looks like and just build it off of that. It's a lot faster. It's a little bit easier to do. Let me show you a cotangent. Cotangent, negative 3 pi over 4. Yo. Yeah. I thought of, yeah, I had it here.
Okay. I didn't see that.
That was driving me nuts. What did I say it was? Thank you. Cotangent of negative 3 pi over 4. What's the denominator? What's going to be your reference angle?
You just drop
What's your reference angle going to be when you have a pi over 4 for a fraction? Pi over 4. It has to be, doesn't it? No matter where it is. If you have a 4 for a fraction, do any of the other ones allow you to get there? So which angle is this going to be working off of? It's going to be working off of 45, right? Oops, well, that's horrible. If I'm looking at a 45, 45, 90, what's the tangent of 45? 1. So what's the cotangent of 45? 1. So what is the only thing you have to worry about here? Yeah. So we have to think about what quadrant did negative 3 pi over 4 wind up in? I'm over here, negative 3 pi over 4. It's third quadrant. Is tangent positive or negative there?
Positive.
So what's the cotangent of negative 3 pi over 4?
1.
1. Yes, sir.
Are we gonna have to memorize?
You have to know that. But remember, you know this, don't you? You can do this all day long. Isn't this just the same thing? Yes, it is. I swear to you, this is the same thing. The only thing that's different from going from to this is that I'm saying that this comes first and this is second. So the cosine of 30 is 1 over, excuse me, root 3 over 2. I'm just making a list. The sine of 30 is 1/2. That's all I'm asking you to be able to do. If you can draw the triangle, you can fill in the ordered pairs. They mirror just that. Okay, they just mirror it. Yes, sir? The ratio of the sides for 30, 60, 90. Remember how we wrote it out always as x? Cotangent and tangent are the inverses of one another. If you go back, if I go back and I say what is just the tangent of 45 degrees, looking at just the triangle, not the ordered pairs. Opposite over adjacent, 1 over 1. What's 1 divided by 1? It's 1. Now, if I looked at the ordered pairs for a 45-degree angle, it would have been root 2 over 2 divided by root 2 over 2, because that's the reference angle for 3 pi over 4. Negative 3 pi over 4, excuse me. Isn't that same thing divided by itself? What would that be? 1. So a lot of times if you're working with tangents, sometimes it's a little bit quicker to go right into the actual triangle itself to look at it. It's a little bit less messy. Secant 11 pi over 6. I'm going to do the secant of 11 pi over 6. What quadrant does that get us into? Gets us to the 4th quadrant. Good. What's the reference angle? Very good. So let's see, pi over 6. When I'm dealing with pi over 6, which degree was that again?
That was
30. Okay. So secant is the inverse of what? Cosine. So the first thing I'm going to do is look at my triangle, if you have a triangle. And I want to see what the cosine of 30 is. What's the cosine of 30? Root 3 over 2. So the cosine is root 3 over 2. Therefore, what is the secant? Very good. It's 2 root 3 over 3. Now, since I'm placed in the 4th quadrant, is cosine positive or negative there? So therefore, what's secant?
Positive.
It's positive. So your answer is 2 root 3 over 3. Again, I'm figuring out my reference angle, plotting it via the right triangle, and working itself through. You got it? Sure?
Yeah.
All right.
We haven't been in this class.
Cosecant, 220, negative 225.
I'm not bored.
Cosecant, negative 225. If you're working with the reference angle, without doing any work, what do you think the reference angle is going to be here?
45.
Why?
325 minus 1.
It ends in a 5. It has to. It's a nice little trick. Your reference angles are either going to get you to 180 or 360. If my angle itself is at 225, the only way I can get to a 0 with that is by adding another 5 or subtracting a 5 from it. It has to be a 45-degree reference angle. The only thing I have to concern myself with is what quadrant does it wind up in. So Negative 225 gets me the second quadrant. My reference angle is 45 degrees. 45 degrees is pi over 4, and it has the exact same sine and cosine value, doesn't it? What was the sine and cosine value of 45? Root 2 over 2. Good. Now, when I'm dealing with cosecant, cosecant is the inverse of which function? Sine. So in the second quadrant, is sine positive or negative? Good. So I know cosecant of negative 225 is going to be a positive value, and the inverse of root 2 over 2. So I need to get the inverse of that, which is 2 over root 2. 2 root 2 over 2, otherwise known as root 2. If you went and did that via the triangle, knowing that your sine value was going to be positive because you're in the second quadrant, if you went and just said, hey, the sine of 45 is 1 over root 2, so the inverse of that would have been root 2 over 1. You could have done it just like that as well. There are a couple of different ways to set these things up. Let's see. Don't use a calculator. What is it, 789? Yep, don't use a calculator. Draw your reference angle. Everything bounces out of that first quadrant. My suggestion when you're writing these out, on the front of your paper, is I would write in my first quadrant and work my ordered pairs. If I don't want to do my first quadrant, I would at least put both of my two right triangles on there. If I put my two right triangles on there, my 30, 60, 90, 45, 45, 90, I can then build everything off of it once I get the reference angle. Get your reference angle, label if it's going to be positive or negative, and go for it.
The 7, 8, 9.
Yes, sir.
So how much is 25%?
Yes, sir. Don't use your calculator.
Are you leaving that up there?
Yeah, you can go ahead and get started. Let me just stop the recording here for
45 what?
60.